So very quickly, yesterday we talked about the different kinds of rules. Remember we said we never actually subtract. We do what's called the additive inverse, which means that we are really changing subtraction into addition and then adding whatever the inverse or opposite is of the second term. We change everything into addition when it comes to integer values. And then we just have to simply follow the two integer rules. If it is the same sign, we add and keep the signs. If it's different signs, we subtract in order of high minus low. And then whatever your high base values sign was will be the sign for your answer, for your solution as well. We also did a couple of practice problems that were involving some word problems, identifying integers based off of key vocab terms like above or below, and then also identifying operations that take place in there for addition or subtraction. And then we were able to touch base very quickly on our counters, dealing with different counters on positive and negatives. Remember, positives and negatives cancel each other out when you have them as a zero pair. So for the very first problem, we happened to have 6 positives that could cancel out with 6 of the negatives. That left 2 of the negatives left over. In a situation like this, what they would probably do is give you the positives and negatives, and you would have to connect it to the correct statement, the correct number problem, and solution that it would belong to. So you would have to make those connections, or they might give you the number statement, like -8 plus 6, and you might have to connect it to the correct picture model and what the solution would be. Okay, so there's different avenues that could take place there. Okay, now our last thing that we're going to be talking about is our number lines. So how to showcase addition or subtraction, which gets turned into addition, on a number line. And this is really important to know how to model it. Okay, so we have our integer number line. Remember, our number lines continue to go on forever in both ends. That's why we have those arrows at the ends of each that showcase that it doesn't stop at -10, it doesn't stop at +10, it keeps going on and on. And then we have our statement here, our -6 plus 2. The way that we work a problem like this out is through movement. Negative values move to what direction? Go ahead. To the left. Our negative values are going to move to the left. So at the top, I want you guys to write that down. Negative moves left, which means positive moves to the what? To the right. Positive moves right. When we talk about negative values are going to have us moving to the left on a number line. Positive values are going to have us moving to the right on a number line. Now, when we are graphing these, it's important to know that we always start at what value. Before we even begin the problem, where should we always start on a number line? What do you think, London? Or not, I'm sorry, I just called you London. Logan? 0. Always start at 0. That's going to be our starting point. So I'm going to write down the steps. These are the following steps. The very first step is to start at 0. So starting at 0, I'm going to go ahead and draw a little line right here at 0. Starting at 0, I'm now going to look at my very first value in the problem, and it's going to tell me the direction I need to move. The first problem I have is a -6, so what direction am I going to move? To the left. So that's step number 2. First step is to start at 0. Second step is to move, and in this case we're moving 6 units to the left. We're going to move 6 units to the left. So we're going to draw a number line above this, moving 1, 2, 3, 4, 5, 6. We've moved 6 units to the left. I'm going to draw another line right above that -6. I'm also going to draw an arrow that showed that I started at 0 and moved left. So I have my little arrow here. Mario, honey, do you need to sit in the front? Do you need to sit closer? Are you sure? Okay. All right, so we are moving to the left, showing an arrow that's pointing to the left. Then from there, we utilize our second value. Our second value tells us from this position that we are at -6 now. From here, we're now going to move what direction? To the right. And how many units? 2 units. We're now going to go ahead and move 2 units to the right. So I'm going to move 1, 2, and then that's it. I'm going to go ahead and put a little star here so that I know that I am done. This is my answer, a -4. Okay, thank you. So what this means is when I work the problem -6 plus 2, it comes out to -4. So I want you guys to go ahead and try problems 2 and 3 on your own. I want you to indicate what the steps are. You're going to model it on the number line, showing the movement that you make for both. And then what is your final answer for that number statement going to be? Okay, so for problem number 2, the very first step that we have to do, step 1, again, we start at 0. Always our very first step is to start here at 0. From there, we're now going to move 3 units to the right. So I'm using that as my green. We're going to move 3 units to the right. And the reason I want you guys to write the steps down is because sometimes you might be having to indicate what the steps were to create that step-by-step process or that number line. So we are moving 3 units to the right. That ends us up at +3. And then for our third step, we're now going to go ahead and move 5 units to the left. So from here, we're going to go backwards 1, 2, 3, 4, 5. And that's where we're ending up at. Our answer here is -2. So 3 plus that -5 comes out to a -2 for our answer. Okay. For problem 3 is a little bit different because it's absolute value. We don't plot absolute value. We actually work the absolute value out first. So you need to actually work your absolute value out first. So I'm going to go ahead and write down that this is technically what? What's the absolute value of -3 again? 3. So this is really 3 plus -7. 3 plus -7. Again, our very first thing to do is to start at what? 0. We start at 0. Always, always, always start at 0. From there, we're going to move 3 units to the right. We're going to move 3 units to the right. So that's 1, 2, 3. That's where we're going to stop there. Okay? After that, we now move 7 units to the left. So starting at that +3, we're now going to move left 1, 2, 3, 4, 5, 6, 7 units. Okay? And that ends us at the value -4. So 3 plus -7 is equal to -4. So there's so many different ways that you are able to work out the same clustering of problems. You can use the rules that you know. Okay, these are different signs. That means that I'm going to go ahead and have to subtract them and keep the sign of the larger number. That gives me -4. I could use counters. I would have 3 positives and 7 negatives. 3 of those positives and negatives would zero out, leaving me with just 4 negatives left over. Or I could showcase it using that number line, moving 3 units to the right and then 7 units to the left, and it ends me at the value of -4. There's so many different things to show the exact same problem. So you need to make sure you understand and know all avenues. Okay? Go ahead and get your computers back open. Right now.